Today is 17th of March 2025. Operating system chapter 1 and 2. Operating I will do a concept review and also some exercises which is important. In chapter 1, we'll talk about overview and about computer system structure. There is hardware, OS, application, program, and users. Operating system is defined by middle between hardware and application system. And in OS operating system, there is controller and resource it works as resource allocator. And there's buses, and through the buses, I/O devices, CPUs, controllers are all connected. I/O devices and CPU can execute concurrently. And for each I/O devices, they are connected with device controller which has local buffer and a software driver to manage it. So I will introduce you. This is page 53, the process of interrupt later more precisely. So interrupt is signal through interrupt vector, which contains an or interrupt service routine. And there is similar thing, which is trap or exception, which is software generated interrupt, which is like when you code, like think of Java. If you divide number by 0.0, then there will be an error. So you should do an error exception. Try exception, then there will be some exception. And so let's see. CPU, now this is the process of interruption. CPU will request IO, then device driver initiate IOs. The device driver will initiate IOs. Then they will initiate CPU instruct device controller who has local buffer to the device controller, device driver, controller or device driver. Instruct device driver who has local buffer to do an IO. Then device controller requests device to do an IO. Then this device controller will do ready and output complete or error generate. Then after that, he will send interrupt. Device controller will notice, device driver will notice after device finish, then he will send interrupt to interrupt controller. Then CPU receiving interrupt transfers control to interrupt handler. The interrupt handler process data written from interrupt, CPU region processing of interrupted task. So CPU interrupt controller set interrupt pin and do the things, and after it finishes, the CPU run again. This is how it works. And now storage structure. There is main memory, second storage, hard disk, and non-volatile memory. For main memory, the memory can do CPU direct access and volatile and able to do random access. Random access is keyword. Second storage, memory structure, register, cache, main memory. This will be nice to be together with page 25, which is transition from user to kernel mode. Transition from user, transition from user to kernel mode. Okay. And in page 13, by the way, this is 10th edition of operating system concept. 10th edition. If you go to page 13, then you can see non-volatile memory. Page 13, non-volatile memory. Non-volatile memory, hard disk drivers, hard disk drivers, hard disk driver, optical disk, magnetic tape, optical disk, magnetic tape, magnetic tapes. So secondary storage is this two, and which is non-volatile. Hard disk is divided into tracks that divide into sectors. Disk has disk controller, and for non-volatile memory, it's if you go this part, it goes more volatile and more faster. Okay, storage device. This is storage device hierarchy. Storage device hierarchy. And there is multiprocessor, which is increased throughput. Before that, wait a second, before that, yeah, main memory. Main memory, it is also good to remember page 15, there is about main memory page 15. Main memory this is main memory, and this is IO device, and CPU. CPU has cache, and this is IO device. For computer system, there is single processor and multiprocessor system. Multiprocessor system, there is it will be good to remember that there is symmetric multiprocessing, and there is multi-core, which is multiprocessor is which is symmetric multiprocessor, each processor does all tasks, and asymmetric multiprocessor, each processor has a task. And for multi-core, one chip contains multiple core, and one shared cache is the difference. I will show the difference. Page 17. There is multiprocessor, and there is multi-core. In multiprocessor, it has symmetric and metric, and symmetric. Asymmetric, for asymmetric, each processor has a task, and symmetric, each processor does all tasks. For each processor, each processor has does all tasks. Does tasks. And multi-core, the big difference is they have one shared cache. One shared cache. In dual core case, it is L2 cache. So there is L2 cache in each CPU core. CPU. But in multiprocessor case, they are just connected with main memory. Main memory. This is the biggest difference. Right. And there is cluster system, which is for asymmetric cluster system, one machine in half standby mode, and symmetric cluster system, which is multiple nodes running app monitoring each other. Apps must be written to use parallelization, and there is distributed lock manager exists to avoid conflicting operations. This is how cluster system work. Cluster system is computer is interconnected. By storage area network. Distributed. The cluster system, clustered for clustered. There is this storage area network. Computer. There is storage area network. For OS operations, now we will look for OS operating system operations. In operating system operations, page 23. Operating system operation. Operating system operation. There's multi-programming and multitasking. Multi-programming. There are multi-programming and multitasking. which is like for multi-programming system, there are a lot of processes together. Process 1, 2, 3, 4, and there is OS. There is dual mode and multi-mode operation. Dual multi-mode operation. There's timer which can be set into interrupt the computer after a specific period so that if timer interrupts, control transfer automatically to the operating system, which may treat the interrupt as a fatal error or may give the program more time. There's a way to manage resources. The core thing is, which is bootstrap program. And kernel interrupt ribbon, which is bootstrap program is load kernel and kernel loads system daemons. Load kernels, load kernel, and after that kernel loads loads system daemons, loads system daemons. So there's multi-programming batch system. So multiple programming loaded in a memory is the loaded in a memory. CPU executes one at a time in turns, which is job scale in turns. This is we so-called job scheduling. And there's the concept of time sharing. Each user gets a short burst of CPU time. CPU scheduling for multiple jobs is needed. And user and kernel mode, which is controlled by mode bit. And timer is timed interrupt to prevent infinite loop process resource hogging. By mode bit. And there is timer, which the timer to prevent infinite loop hogging. infinite loop resource hogging, and now there's process management. Each thread has its own program counter. So OS can create, delete, resume yield process, sync, deadlock handling is possible. There are a lot of management. There is process management. You see, process management. From resource management is page 24. Resource management. For process management, important thing is extra task as well. It's right as its own program counter. I forgot the word here. It's PC, and I think it was not maybe program counter. And with can create, delete, create, delete, here, resume process, resume process, resume process, and sync communication deadlock handling. They do sync communication deadlock handling. Sync communication deadlock handling. For memory management, they do allocation and deallocation memory. Alloc and dealloc, alloc memory. And there's also, this will be page 28. And for caching, cache management. The cache management. As info moved from floor to vector memory, cache checked before checking memory. In multiprocessing cache coherency, all CPUs must have the most recent value of a variable. And there's IO subsystem, managed memory, protection and security. Users have ID or they are in group ID with different privileges. Protection and securities. And for computing environment, it will be good to remember what we have. This is and page 35, the distributed system is 5 distributed. Page 39 bitmap. 39 bitmap. Page 40 computing environment. Page 40 computing environment. Watch as traditional mobile, traditional mobile client and server system. Client server system peer-to-peer. Now and real-time embedded. And for operating service systems, there's UI type, which is GUI and CLI, and there's system call, which is API gives access to operating system calls. So it will be very important for noticing system call. System call provides an interface to the services made available by operating system. System call will be good to explain on page 65. Page 65, system call. If your system call will such as printf, then printf is that you should show something in monitor, so it goes to system call interface or interface. Then it moves to kernel mode. And interrupt is different concept. Server is different concept. Remember, it's different. Both are going to kernel mode and do things and system or and if it return to again. In system call, important thing is you use API. This is API. And when you do, there are types of system calls such as process control, file management, device management, information management, communication, and protection, such as fork, exit, wait, process control. The new process, fork, exit, right. And when you pass parameter to operating system, there is three ways, which is pass parameter in register and address of block, give memory address stored in a register, or stack way, in a stack way, parameters path in stack. This is parameter passing. Three ways of parameter passing. Three ways of parameter passing. So there is process controller. Yeah. Right down more. File management. File management, device management, info management, such as get, set, and communication, send, receive, communication, and protection. Protection, such as get, set, permission, as a permission and allow, deny access, allow, deny, and for operating system structures, there are mechanism and policies, which is policies is what will be done, and argument mechanism is how to do it, and very specific code will be mechanisms. So in page 81, there is operating system structure. 2.8, there is 81.8, all as structures, which is MS-DOS, MS-DOS, Unix. Unix is monolithic, and layered, modular functions use lower layer function. And microkernels and loadable kernels. So before that, layered approach is you split you literally layered, so it is difficult to communicate in between layered kernel, and there is microkernel and loadable kernel module. Microkernel and loadable kernel module. This in microkernel keyword is independent. For modern system, they combine monolithic and modular. This is important part, so we will cover it deeply next time. Thank you very much today.